today's session basically is focused on FreeRtr capabilities to create tunnels and to just connect to different tunnels. So I have prepared a small demo. I hope you can see now the slides. Probably yes. Can you? Yes.
Yes, we can.
Okay, great. So basically, there will be just two routers. Let's say router 1. Let me try to put some pointer here. Yeah. So router 1 and router 2. Both of them are going to be connected to the internet, right? Through this router here, which is external, let's say. Then we will have an internal connection between them, which is via Ethernet 2, as you see here. And then we have a couple of networks where I have just put a VM on each side just to show the effect. Okay. So basically, the first thing will be to just put some addresses. So basically, this is the addressing we are going to use during the demo. The FreeRtr is going to configure itself via dhcp from this router here on both sides. Then we will just put some addressing here to have this connection between both of them, so that, and it will be the one used to create the tunnel between them. And then we will have, of course, some dhcp for these guys. So basically, we are going to configure also a FreeRtr as dhcp server. So once we have that, we can create the two VPN tunnels. We are going to create one for openvpn, one for wireguard. This will be the addressing used there. And finally, since we haven't spoken about how this guy is going to be able to speak with this guy, we are going to put RIP before on top of these tunnels. So basically, this prefix here is going to be advertised to this guy here. So they will be able to connect between them. That's a big the idea of the session. So second, so I have created, as I was saying, two VMs. So basically, these two routers are running the QCO2. You can download already from FreeRtr.net. So it's already available. FreeRtr.net. Here at the bottom, you can just download the QCO2 version of the system and just create a VM, and it will be running. It's already starting, hopefully. And then we have the two hosts that are going to be connected to that. So this is already started. So I'm going to change to the serial console. So you can see here we have FreeRtr already running. And on the second one, in serial console, we have also FreeRtr running. Okay, just for the sake of being more comfortable for you, I will put it here. So I'm going to put the router 1 on top. Okay. Whoops. Second. Disconnect this one. Disconnect this one. Just for the sake that you can see it better. Okay. And same thing here goes for domain. Domain 2. Okay. So we have our both routers here. Right now they are completely unconfigured, or they should be. Okay, so they have nothing basically. So first of all, we are going to provide them with a host name so that we can differentiate them easily. We enter the config mode. Okay. So now we want to activate, if you remember the slides, we said we wanted DHCP on Ethernet 1. So that's what we are going to do on both of the routers right now. So, oops. First, as you know, because you have already attended the previous webinars, we need to create the VRFs we are going to use. So basically, I'm going to define VRF init, which is one VRF definition. Sorry. So basically, that one is the one facing the router or the internet connection. And now we can configure Ethernet 1. In this case, we are going to set the VRF forwarding. So we are going to create as init, okay? And we are going to just put an client enable. Okay, so we cannot do that. What happens here? We need an IPv4 address for that. We're just putting random. Oh. With that, we are activating the protocol, and then we can define DHCP. Okay. If we want also to know to learn the default gateway, then we have this option, which is IPv4 gateway prefix. Okay, and then we can just say the prefix list. In this case, I'm not interested in it, so I just leave it like that. I will just shut down, make sure that it's not shut down. And we should see that Ethernet 1 is working. So if I do interface Ethernet 1, it already has an IP address. Okay. So, and I should be able to ping router hub. Okay. It's working. So same thing is going for the router. Remember that in FreeRtr, we always work with this VRF concept. So basically, we need to assign it. Push it down. And okay. Okay, that's working. So basically now we have FreeRtr working as a DHCP client. That's something we already wanted. Now we are going to configure the interface between the two routers. Okay, if you remember, try to go back. Okay, so this one here. Since I'm going to use it for just tunneling, I'm going to create another VRF for it. Okay, so we are going to see VRF definition, and I'm going to set, just to use the same one I was using. Okay, VRF. Okay. Oh. Okay. Okay, so I'm creating the same VRF on both sides. And now, of course, we can configure Ethernet 2. as we said, we are going to use VRF forwarding to VRF, right? And we are going to set the IPv4 address as 10.10.1.0. Okay. Push it down. Same way on the other router. We are going to set the address here. Okay. Oops. Never forget your VRF. So as you see, already FreeRtr is controlling that we are not missing anything and not doing as I usually do, forgetting things. So now we should be able to ping ref. Okay, and it's working. We can ping it. That's cool. So now we were trying to create two networks so that our hosts have some kind of connectivity, because if not, they are completely useless. So we are going to configure Ethernet 3. If you remember, we had this. So in Ethernet 3, we are going to define this network here, and we are going to set up dhcp. Okay. So first of all, we need, of course, a VRF, right? We didn't create it, so we are going to create it. We are going to call it internal, okay? And now we can, of course, configure 3, right? VRF internal, VRF forwarding, sorry. IPv4 address, we are going to set 10.10.1.54. I think I can do /54 anyway. So that would be our address, and that should be by now. On the other router, we are going to do the same. So internal, okay, IPv4, sorry, interface 3, VRF forwarding internal, IPv4 address, and 2.1.2.5.5.0, no shutdown. Okay. So basically, we have Ethernet 3 also up. Okay. But as we said, we wanted our hosts to have the dhcp configured. Okay. So basically, what we are going to do is in FreeRtr, we have the concept of server. Okay, in this case, we have only the telnet, which is the one that would give us remote access, but we are going to define one dhcp4 server, which we are going to say Ethernet 3 as the name. Okay. In this one, we are going to set, of course, VRF, right, which is internal. Remember. Then we are going to say the pool. What is the pool we have? 128, and 254. We also say what is our net mask. Okay, we say this. We say what is our gateway. What else? We may need a lot of things. So as you see, FreeRtr is plenty of them. No problem there. And if I didn't miss anything, because I did it in my memory, it should be basically working. Yeah, I think so. So basically, if I go to our host, which we said was going to be here, domain 1, just open it. We have a console here. Good. Let's make it bigger for you. Okay. Okay. Now, if we do this, it's not configured. But if we try again, oh, sorry. It should get the address. Oh, it's not working, of course, the demo effect. Why it's not working? Basically, if you look at it, well, it looks pretty good. We say which is the BRF, but we didn't say which is the interface we are working on, right? Predix is saying, yes, you forgot that. And hopefully now, this guy, when he tries again, he gets its IP address. So we have the dhcp server in our FreeRtr, which is quite nice because we can see the lists and so on from our, and it's interesting. Let's configure also this one. Server HTTP4 H3, and then we have a lot of configuration, which is like 228 and 254 gateway. Myself, I will be your gateway mask. This one interface. Mask interface 3 and BRF. And the other host should have IP address. Okay, so up until now we are creating our, we have been creating our scenario, and it's fine. Just took the profit of this show to show you the latest from FreeRtr about dhcp. So now we are going to create the wireguard tunnel first. So to create the wireguard tunnel, first of all, we need to generate some keys. In the case of wireguard, we have this wireguard gen key command with which we will create the key, the private key and the public key. So basically, in our configuration, we have to cross the public keys so that basically one and another have the public key from the other one. So basically asymmetrical cryptography there. And what we are going to do is first create a crypto for a FreeRtr. So basically, we are going to go T again, okay, and we are going to create the wireguard crypto IPsec, and we are going to say wireguard1. Just to have the same I have in my notes, so that I don't, if I have to copy paste afterwards, it's easier. So we just have this one, we are defining the crypto, and here what we have to define is the key. Okay, in this case, I have here the keys already prepared. And we paste them here. So if we do show run crypto, we will see that we have it already encoded, so that FreeRtr is already not showing it directly. Just for you to know that, of course, these two parts are merged manually, so it's not like it's done in an automatic process. You have to do it yourself, but once you have done, just put them there, and that's it. So now we are going to config crypto IPsec wireguard2, and no, sorry, wireguard1. Same. So I'm going to set the key for this one, which is completely different from the other one, okay? Because we have our own private key. So each router has its own private key and has the public key from the other router. And now we have to configure that. How do we configure that? So basically, we say interface 1, and we are going to say which is the tunnel BRF, because we want just to what is the BRF we want to communicate, let's say with that. So we are going to use internal. Okay. We say which is the protocol protection. In this case, it's wireguard.
So, sorry, Jordi. You are configuring Ethernet 1, but on the graph it's on Ethernet 2, or the tunnel is not.
Tunnel 1. It's not Ethernet 1. It's tunnel 1. I'm defining a new interface.
Oh, sorry.
Okay. And so sorry. Yeah. No, my bad. So if you remember this graph, I'm configuring this. Okay. I already configured
Perfect. I heard Ethernet 1 and it was tunnel 1. Sorry for interruption.
No problem. So basically, now we say what kind of protection we want. FreeRtr has some options here. In this case, we are going to use work. Okay. Oops, sorry. Oh no, sorry, I missed. This makes reference to our wireguard 1 definition. I was reading the wrong line. So we have some modes. Sorry, these ones are the ones that FreeRtr has. In this case, we are going to use wireguard, as we were saying. Okay. You see, there are a bunch of them, so any would do. We see what's the source of our tunnel. In this case, it's Ethernet 1. Ethernet 2. Sorry, we just say what's the interface. And with the destination, we use the IP address of the other end. Okay. Now, what are we going to forward there? I think this one is wrong. Yeah, I will fix that. So, what is the one we want to forward? It's internal, as you remember. And I said that I was going to use protection. Sorry, it's BRF, the tunnel BRF internal, and that's wrong. Okay, we're going to use BRF, right? That we defined before, if you remember. Apart from that, we are going to give it an IPv4 address. It's 10.10.2, and we are going to finish. Of course, this is useless if we don't have the other side. So we are going to configure tunnel 1, and we are going to do the same thing. To BRF, okay. Destination and 1, BRF forwarding, internal, and my IPv4 address is 10.10.10. Okay, we are just setting the addressing. So basically, we might be able to ping the other side, hopefully, in some seconds. So let's give it a try. And we are going to use
not internal.
I guess you use the same IP address for both sides.
Did I do it? Sorry.
I guess so. I saw that you put the same IP address for in both. I don't know.
It's different one.
No. You say VRF internal. Is it correct?
Yes, there is.
No, it's VRF. It should be VRF.
We see that the tunnel is down, so something is wrong there.
Jordi, Jordi, in router 1, you are using.
Sorry, there is a lot of noise.
Sorry.
Rafael,
Okay.
I mute you. Oh, that's it.
Yeah,
Sorry,
Jordi,
sorry.
Jordi, as Rafael mentioned, in router 1, you have used the same IP address as in router 2 for the tunnel. Show run tunnel 1. Yeah,
Okay, that's it. Yeah.
that's it.
Yeah,
That's
yeah,
it.
this one.
10,
Sorry.
10, 1, 10, 2. So it should be 10, 10, 1, 10, 1. Just a copy paste error.
Yeah, and the wrong thing is the worst is I didn't copy it. I mean, didn't copy paste it. Okay. So hopefully now we can ping it. Still, I don't see the tunnel is up. Okay.
Can you show run interface tunnel one on RTR2?
This one?
And yes, and what about tunnel one?
Tunnel one.
You forgot the tunnel mode.
I forgot. Oh, okay. That's the good thing to have Saba around. Tunnel one. Tunnel mode. Firewall with that, right? So okay, it's working, right? Lucky me. So the idea is to show that basically if we try to ping and one with BRF stand, right? If we make we do this, okay, this is basically I'm going to just see the traffic there. Well, we see some traffic here. If we just ping like this, the other way around, okay, and we see a normal ping. Okay, we should see here the ICMP around. Let's see. Yeah, ICMP as you see here. Okay, so they are there. But then if we do it with, of course, this one, internal, our traffic is encrypted and we cannot see the ICMP anymore. Okay, so we are basically sending the traffic through the tunnel, right?
Yeah, may I ask you a question, because something
Sure.
basic that I don't understand is your tunnel is connected to, how the tunnel is connected into the VRF internal.
Yeah, so basically, if you look at the configuration from the tunnel, we have two VRFs. One is the one that is going to transport the tunnel, and the other one is the one that is going, the tunnel give access to, let's say.
Okay, perfect, good.
Okay, so that's basically the idea behind it. So basically, as you remember, we have internal. So basically, our Ethernet interface Ethernet 3 is in internal, or should be in internal. That's it. And then we have Ethernet 2, TAN 1, which is in internal, right? So basically, they are in the same BRF, so potentially they could communicate between them, right? But the thing is, we didn't say any way to this network how to reach this one, right? So in theory, if I try to ping from our host, ping 10, 2, 1, let's say, of course, I get destination and reach. Okay, so basically, we are going to set RIP on our FreeRtrs, which is simple, and we are going with that to have this connectivity working simple. Okay. So basically, what we are going to do is just define router RIP4. Well, as you see in the router, you have some options here. Saba put some options, so yeah, you just can play with them. A bunch of them, so some of them I don't know what they are, so it's incredible. And once we are defining this, we say, of course, which VRF we are going to work, okay? And we are going to say what to redistribute. So what kind of routes we want to redistribute. As you see, we have a bunch of them again. I'm going to say static. Yeah, I like it. And connected. So basically anything that is connected is going to be redistributed. Okay. Okay, we have RIP. Router RIP for one is just a process ID, so you can use several of them, so you can have multiple RIP working basically. Maybe Saba wants to give more insights of that. Maybe not. Okay, but unless I'm wrong, I'm still not able to ping. So basically, why? Because if we inspect summary, there is nothing here. And why there is nothing here? Because basically we didn't say which of the interface is going to talk RIP. So we have to go to where? To our tunnel. This was like no, it was RIP. No. How was it? Yeah, okay, router. For we say the same process ID, and we just enable it. Same thing goes here. And as you see, already has been discovered. So before RIP one summary, there should be someone here. Again, I missed something. Okay, now. Okay, now we have it here. And of course, we can inspect what is the originate, are basically the routes I'm announcing, and what are the data. This is the database, so basically what I have learned, and therefore this guy is already pinging the other one, and it's pinging through the tunnel, of course, and the RIP interaction between the two routers is already protected by wireguard. That's basically tunneling with FreeRtr, and then of course we can create another tunnel with openvpn if you are fancy about it. What do you say, Frederick? Do I give a try? Yes. Okay.
Of course.
Okay.
You have almost everything in place. You just have to replace the crypto,
yeah,
and the tunnel mode, and that's it, I think.
Yeah, I'm going to cheat a bit, so I'm going to just create another one by copy pasting. Sorry, this time it will be a bit faster. But basically, the big difference is that in the case of openvpn, of course, the key is symmetrical. So basically, we have the same one on both sides, and we have in this case des as the ciphering and hash with MD5. Of course, we can change the hashing here or the cipher to 3 des or whatever we want. Okay. And then One option would be to just replace our tunnel mechanism, but why not create another tunnel? It's free. Interface. And for that, we are going to, copy paste again so that we don't take a lot of time. And the process is exactly the same one as beforehand. But in this case, of course, we are going to use mode openvpn. Apart from that, as you see, the configuration is exactly the same. And now we are going to configure the second router. And the channel 2. And I show the summary, we have tunnel 2 up, so we should be able to ping and then 11.1 be ref internal, and we should be pinging through the openvpn. Okay. So we have both of them, and now the only thing we may want to do is just to add RIP to the secondary tunnel also. Why not? Let's see what happens. See. For show IPv4 RIP 1 summary. We have tunnel 1. Hopefully, should see tunnel 2 also at some point. Yeah, there it is. Okay. So that's pretty much all from my side. I think I don't know if there is any question or something. Sure. You're mute, Frederick. You know that.
Yes.
Okay.
So thank you. Yeah, thank you. So thank you, Jordi, first for showing this example of how to establish both wireguard and openvpn tunnel between two routers. One thing that is really important to note here is that in this example, Jordi used two endpoints of the tunnel, point A, point B, being a part of being FreeRtr itself. Of course, it's I would say maybe not obvious, but I would state it anyway. The idea is that you can establish this tunnel with any host. So the remote end can be I would say an OpenVPN compatible router, or it can be an Ubuntu running WireGuard. It will just work. These are part of the, I won't say standardized. It's not a standard like an RFC defining the ETS, but just to let you know that this is possible to have different type of host altogether. One thing also that is important to note here is that FreeRtr is able to handle a whole bunch of variety of tunneling techniques. And here, for example, I have in my home routers, I have 3 tunnel, 2 WireGuard tunnel, and 1 OpenVPN tunnel. The only the only thing that is quite important to sorry, I just lost connection because I put the wrong. Oops, the demo effect.
Demo effect.
Okay, so what is important when you want to establish a tunnel? You create a crypto defining the mode encryption you would like to run. So here it's WireGuard and OpenVPN. Then you are thinking about applying this tunnel mode in a specific tunnel. For example, here. This is a real tunnel that is up and running. So here you define the tunnel mode. And if you look at it here, this is a specific tricky example. The underlay is running IPv6. So the tunnel transport is based on IPv6 reachability, which is a public IP address. And the tunnel is actually IPv4. So this is something quite interesting if you want to run specific, if you need to access and cross IPv6 only network. So this is really what is interesting. So just as a reminder, you define the crypto and then you apply it in a tunnel. I'm taking the opportunity to say hello to our friends from UFES, from Brazil, who are connected. And we have Rafael here. One thing that you can do, for example, is that you can create an underlay that is based on a specific different tunneling techniques. We can create, I would say, a Polka tunnel, for example. And then we associate this tunnel mode to this interface tunnel. Of course, it won't be encrypted, and it's not like a VPN tunnel per se, but this is the idea of how to establish this tunnel. Again, Saba has created a lot of encapsulation possible. Here, it's like chasing a Pokemon. Every tunnel mode you can find in the world is almost supported. You have he just added an empty relay, which is a way to provide an empty relay function to FreeRtr, which is a way to open the door for a receiver not into a multicast network to reach multicast source. You have a beer tunneling, you have the LSW for the old dinosaur like me. I just remember some souvenir. We have ERSPAN, GNIV, GRE, and so on and so on. So feel free to experience all this type of VPN encapsulation. Some need, of course, crypto stanza, and the others are simply configured. One thing that is important also is that in when you establish tunneling techniques, if you are running, for example, DPDK flavor, and you have a CPU that is AES-NI friendly, which has a AES-NI, I would say, instruction built in the CPU, you can leverage, of course, AES directly via hardware-assisted technique that is provided directly and built in JVM and DPDK. So, Saba, would you like to give us some final words? We have 15 minutes.
Not too much.
Not too much. Okay. So again, this tunnel, you have a lot of encapsulation technique. Feel free to experience it. It's really incredible. Of course, OpenVPN and WireGuard might be the one that you will choose if you would like to provide a VPN, I would say, function to your CPE or router. This is the most useful. And do you have so far any question?
I have one for Sava. Sava, the ICMP encapsulation is what I think.
Yes, so basically then the tunneling happens within ICMP echo reply echo request. It is very good idea to traverse firewalls.
It's great. It's great.
Yeah. Something that is also not obvious for me is this encapsulation. This is a packet over UDP. So not sure if you have read some documentation, and also feel free to provide additional insights about. But as we described during the last session, is that we have a tool called pkpint, which is basically a tool to stitch 2 points using a UDP socket. And the point in stitching this to open a UDP tunnel is to provide packets on top of it. And this is the packet over UDP, the packet over UDP encapsulation. So Jordi, thanks for this presentation. I'm not sure if some have some questions about FreeRtr. Also, one thing that is not obvious is that for those who have missed the last sessions, Jordi has uploaded the first recordings on the YouTube channel, and I'm not sure what is the status now, but technically you should be able to see this video. Basically, these are 1 hour video where we specifically deal with a technical point related to FreeRtr, and feel free to look at them if you want to know more about the subject.
So guys, thank you from the outside. I'd like to say thank you, Jordi, Frederick, to invite us to attend this. Sorry, because our last 2 weeks we were a bit overloaded here in Brazil, but because it's the final finishing some half term here. So, but Jordi, thanks for your explanation. So you can clarify a bit more how FreeRtr works, definitely. So thank you very much.
My pleasure.
No problem, Rafael. I'm not sure if this can take the same form, but for example, what we can with Polka, we can think about a specific encapsulation and make this communication on top of it, so people can pour traffic into a specific Polka tunnel. But maybe we'll deal with this not details, but we'll deal with this topic with Xaba in further and subsequent sessions.
Yeah, I heard what you mentioned about the tunnel. It should be like behaving as a Polka instead of behaving as a wireguard or openvpn normally, or scripting some data. So it sounds good on that way.
Great.
You implement it, I will demo it, Rafael.
Yeah,
I promise.
Yeah, sorry. Yeah, for sure.
Anyway, Jordi, any final words from your part?
No, just to say that the video for the first session is already up on the YouTube channel. We don't have nothing like a fancy URL because basically we depend on subscriptions for that. So it's a really ugly URL. But anyway, we will circulate it in the Twitter, right, Frederick, and maybe also in the mailing list, so that.
Could you circulate the users rare the list rare users, please, Jordi? Because I don't know if I have the Twitter one. The YouTube channel that you will publish these videos will be good too for us, especially because Christina I think wants to see this video as well. So.
Yes, that's why we created the channel, so that you have access to it anytime when you have some spare time and you want to hack. So basically, they will be available there. So the first video is there. The second one should be soon, and this one I will put it afterwards. So basically, they will be there for you to consume.
There is a YouTube videos YouTube channel only for the RARE project, or is your particular channel?
It's for RARE, so it's basically just for this
okay.
event.
Yeah. I was digging about if I could find this YouTube channel, but I didn't find. Sorry.
Simon already sent the URL through the chat, so you can just access it. Anyway, we will forward it through the mailing list and also the Twitter account. Yeah, please subscribe and thumbs up.
Okay, nice. I got it now. Thank you very much.
Well, thank you all for being here. Let me do one last thing before shutting down the session. I would like to remind you some, I would say, must-have URL if you are really interested in FreeRtr. So I invite you to look at the official FreeRtr website, which is where you will have tons of information. And we have also the same documentation website that I presented at the last session, where we are providing a getting started page. So feel free to go through this page. Of course, this documentation will be will provide more insight soon. The idea here is to just find the time to write new documentation on specific topics. And this is you are lucky because I did not announce it yet, but this is a new article that is published on the blog here. Which is blog.freertr.net. And the idea of this new article is to show you that the RARE-freeRtr architecture is following a totally disaggregated model. So what does it mean practically? It simply means that we can run each component in different hosts. So these two. So here we are taking the example of a FreeRtr trying to establish an OSPF adjacency. Okay, and in reality, this host is composed by three processes running on different hardware. So this can be a container, a VM, or a bare metal server, and same for the BF4WAL, which is the interface between the control plane and the data plane. And then we have I would say the basic DPDK P4, the DPDK router, FreeRtr, sorry. And you will see that it will just works. And this is a way, for example, to have a fully decentralized hardware at the customer side and having basic functionality that is having a basic connectivity toward the control plane that can be hosted in a different sites. So this is just for information. I will announce it right now, but as you are here on the call on the VC, you will be the first to know about that.
I have a question, Frederic. So
yes.
And maybe Sava also. So if I made this kind of distributed deployment, could there one FreeRtr control multiple P4 switches?
Well, I can give Saba the floor because he has a very good he has a very good explanation answer to that.
Yes, you can. For example, you can do some naming conventions with the SDN interfaces, and then you can run multiple P4 LANC servers to serve multiple switches, and then you can run routing protocols in between them through the SDN interfaces.
So if someone feels like 65 ports of 100G is not enough, you can have another 65 ports, and that's it. With one manageable router, let's say.
Yes.
Exactly. So so this is one of the first answer, and the answer to the other answer, Jordi, is that FreeRtr is able to run what we call VDC, virtual device context. So what is a VDC actually? It's simply the possibility to have one global FreeRtr that is able to manage several virtual FreeRtr underneath. And each of these FreeRtr can have a server P4 long stanza that is piloting different type of data plane. The data plane can be mixed. It can be a GPDK data plane, it can be a pure software data plane powered by a TCP DMT pickup library, and it can be also a P4 switch. And this is I would say one of the beauty of modularization and this disaggregated model. However, I will be honest with you, I never tested this in I would say a very, very long distance situation where you have your control plane that is 100 milliseconds of RTT from your data plane. I'm pretty sure you will have to tweak the IGP. But luckily, the standards are made to make things robust. And it's not uncommon, for example, in service provider to have one or two provider a core router, P router, that is connected to 200 kilometers from their PE. So I've experienced this. I've deployed some router in the world for big telcos, and this is some situation that this is not unusual to have such long distance. So, and it was working. However, of course, the timers for IGPs and BGP has to be tweaked so that failover can work correctly.
Thank you.
So many thanks to all for your presence, and I suggest we talk to you next week. For any reason, if you have some questions, feel free to prepare them and send them to the list, and if it makes sense, we can even have a discussion on during the next session. And so far, thank you again, and talk to you next week.
Bye-bye.
Bye.
Bye-bye. Thank you very much. See you. Bye.
Thank you.
Thank you. Bye.